Namaskar. In this tutorial, we will go through a past paper question based on the concept of mean and variance of a continuous random variable. The question says the length of time t minutes that a passenger has to wait for a bus at a certain bus stop is modeled by probability density function given by f of t is equal to 3 by 4000 multiplied by 20t minus t square when t is varying from 0 to 20 and f of t is equal to 0 otherwise. In the part A, they are asking us to sketch the graph of y is equal to f of t. If you see, f of t basically for the interval 0 to 20 is a quadratic function, correct? So that means for the interval 0 to 20, it will represent a parabola. The graph of f of t will represent a parabola. Okay, but which type of parabola? Here the coefficient of t square is negative. So that means the graph of f of t for the interval 0 to 20 will represent a parabola with a maxima. And f of t will be equal to 0 otherwise, correct? So let's draw the sketch. So this will be the graph somewhat for the interval 0 to 20. Let me draw the axis here. To the left of 20, let me bring a little bit this near on the origin side. Yeah, correct, this is okay. After 20 it is 0 and to the left of 20 also it is 0, correct? This is my f of t and this is t. This value is 0, this value is 20. Okay, so we have sketched our graph of f of t. Now part B, what they are saying for the part B, they are saying hence explain without calculation why e of t is equal to 10. That is the mean of t or the expectance of t is equal to 10 without calculation. If you see this particular graph, this graph for the interval 0 to 20 actually has got a line of symmetry here. It has got a line of symmetry here, okay, between the interval 0 to 20. So what we have learnt, if the graph of f of t has got a line of symmetry between a given interval, then mean of that particular random variable basically will be equal to what? Half of the endpoints at some of the endpoints of the interval, correct? So here the interval is 0 to 20, so it will be half of 0 plus 20, or the mean of the endpoints of the interval. So it will be 20 divided by 2, which is equal to 10. So it has got, since it has got a line of symmetry here, we can directly say e of t is equal to 10. Okay, let's go to part C. Part C, they are saying find variance of t. Now what is variance of t? Variance of t is equal to variance of mean of t square minus of square of mean of t, correct? So here mean of t we already know. We need to find out mean of t square. Let's try to find out mean of t square first. So e of t square will be equal to what? It will be equal to integration of t square into f of t with respect to t for all the real values of t, correct? But here f of t is defined for the interval 0 to 20 only. So I'll take this as interval from 0 to 20 t square into f of t is what? F of t for this particular interval is 3 by 4000 into 20t minus t square, and this we are supposed to integrate with respect to dt, correct? So what I'll get here, this will be equal to 3 by 4000 I'll take outside and I'll integrate inside. So I'll get integration of 20t cube with respect to dt minus integration of t raised to 4 with respect to dt, correct? So what do I get here now? This will be equal to 3 by 4000. This integration will give what? 20 will come outside, t cube integration will be t raised to 4 divided by 4 minus integration of t raised to 5 will be t raised to 4 will be t raised to 5 divided by 5, and I can put the limits 0 to 20. So therefore e of t square will be equal to what? 3 by 4000. If I substitute the limits, what do I get? I get this as 20 raised to 5 divided by 4 minus here 20 raised to 5 divided by 5. And if I substitute 0, so what I'll get here, this will be 0 and this will be 0. So that means the subtraction part will be 0 minus 0. Correct? So this will be equal to what? If I solve this whole bracket and I multiply by 3 by 4000, so what do I get? I get this as 3 into 4 into 10, which is equal to what? 120. Okay. So this is our E of t square. So therefore variance will be equal to what? So the variance of t will be equal to 120 minus of E of t ka whole square, that is 10 ka whole square. So this will be equal to what? 120 minus 100, which is equal to 20. So the variance of t is equal to 20. Okay. Part D. It is given that probability of t less than 10 plus a is equal to p, where a is lying between 0 to 10, and they are asking us to find probability of t being less than 10 minus a and t greater than 10 minus a and t less than 10 plus a in terms of p. Now for solving this particular part of the question, we will require this graph, this sketch. So I'll take a snapshot of this sketch. Okay, and I'll take a new page. Okay, so what they have given us probability of t being less than 10 plus a is equal to p. Okay, so 10, this part was 10 of ours, correct? So 10 plus a will be to the right of this particular 10. Somewhere here we can say this is 10 plus a, this point here is 10 plus a. Okay, and this particular probability, this particular area under the graph here is nothing but the probability of 10 plus a, correct? This probability of 10 plus a is equal to p. This value they have given as equal to p. Okay, but they are asking us what? They are asking us probability of 10 minus a being less than t is less than 10 plus a. So how do we find out that particular part? So if you see this being 10, this being 10 plus a, because the graph is symmetrical about 10, so this particular point here, okay, will be 10 minus a. This point here will be 10 minus a, correct? So they are asking us this particular region ka probability, that means area under this particular graph for this particular region. Okay, so here if you see probability of t less than 10 plus a being equal to p will be equal to what? Will be equal to, this is probability of t less than 10 plus probability of t between 10 and 10 plus a, correct? Let me bring this down. This is this part they are asking. So this is equal to what? Probability of t less than 10 basically will be equal to what? 0.5. Why 0.5? Because the graph being symmetrical about 10, to the left of 10 the area under the graph will be 0.5, and to the right of 10 the area under the graph will be 0.5, so that the total area is equal to 1, correct? Plus this probability of 10 less than t being less than 10 plus a, this particular value is equal to what? This particular value we don't know. So can I say this particular value somewhat as p1? So can I say p is equal to 0.5 plus p1? So therefore can I say p1 is equal to p minus 0.5? That is probability of t being less than t 10 plus a is nothing but p1, which is equal to p minus 0.5, correct? So because the graph is symmetrical, okay, on the either side of 10, so therefore can I say probability of 10 minus a being less than t being less than 10 is also equal to p1, correct? So if this is equal to p1, so that means this is also equal to p minus 0.5. So therefore this particular probability which they are asking, this will be equal to what? This will be equal to, this will be equal to probability of 10 minus a being less than 10 being less than t being less than 10 plus probability of 10 being less than t being less than 10 plus a, correct? So that is equal to what? That is equal to 2 times p1. P1 plus P1, correct? So this will be equal to what? 2 times P minus 0.5. So this will be equal to what? 2P minus of 1, correct? That's it, part C of the question. Let's go to part D. What is part? That is part D, sorry. Let's go to part E. They are saying find the probability of T being less than 8, T being greater than 8 and less than 12. Part E, probability of T being greater than 8 and less than 12. Okay, so if we have to find out this particular probability, this will be simply the area under the graph for this particular interval, correct? So that will be equal to what? Integration of f of t with respect to t when t is varying from 8 to 12. So this will be equal to what? This will be equal to f of t was 3 by 4000 into 20t minus t square. So 3 by 4000 I can take outside and I will have to integrate 20t minus t square with respect to t when t is varying from 8 to 12. Okay, so if I integrate this, what do I get? I get this as 3 by 4000 into 20t square by 2 minus of t cube by 3 when t is varying from 8 to 12. So let's substitute these values, the limits. What do I get? 3 by 4000. If I put 12 here, 12 ka square is 144 and 144 into 10. So it will be 1440 minus, similarly if I put 12 ka cube here, divide by 3. So what do I get? I get this as 576. So for the upper limit, I'll get 1440 minus 576 minus the lower limit. Let's put the lower limit 8 here. So if I put 8 here, so it becomes 64 into 10, that is 640 minus 8. If I put here 8 ka cube, divide by 3. So what do I get? I get this as 512 divide by 3. Okay, so this is equal to what? If I solve this whole bracket and I multiply 3 by 4000, what do I get? I get this as 37 by 125, which is equal to 0.296. Okay, so this is part E. What is part F? Give one reason why this model may be unrealistic. Now what is this particular model? The model is basically for the waiting time of a passenger for a bus at a certain bus stop, correct? And the waiting time they have given from 0 to 20 minutes. It has got a function value and otherwise it has got a 0 value, correct? But it is possible that the waiting time can be more than 20 minutes, correct? So that's the reason we can say that it can be unrealistic. We can say waiting time is restricted to 20 minutes only. Waiting time restricted to 20 minutes only. In reality, it can be more, correct? In reality, can be more. Okay, so this is part F of the question. If you want to understand and practice other concepts of the continuous random variable, then do watch the playlist coming on the screen in front of you in next few moments. Radhe Radhe.